Hello, PLP Geometry. Welcome to the third lesson in Unit 5. So again, we're still here in Unit 5. We're still talking about parallelograms. And we're eventually going to get to the coordinate plane actually in the next lesson. So again, we're transitioning away from parallelograms and into the coordinate plane. So this lesson, lesson number 3, is on special parallelograms. Special parallelogram. So we learned in the last lesson the 5 ideas about a parallelogram, right? Opposite sides parallel, that's the definition. Opposite sides congruent, opposite angles congruent, consecutive angles supplementary, diagonals bisect each other. The 3 objects we talk about today, the 3 figures, they have all those properties, but then they have some other properties that make them special, right? So I think you've heard of these terms before, so hopefully it's nothing new to you, but let's just dive deeper. So the first term is a rhombus. Now a rhombus is a parallelogram, so notice I use the symbol, with four congruent sides. Now some people call this a diamond, right? So when you were a kid, maybe it was a diamond, right? So I'm going to draw this picture over here. So it looks like a parallelogram, but instead of having the opposite sides congruent, all 4 sides are congruent. So this time it looks like a square kind of angled on its, angled. Good. And we'll call this PQRS. So in this picture, we know that all 4 sides are congruent. Now, a rhombus has 2 other properties. These other properties both have to do with the diagonals. So let me go ahead and draw the diagonals in. So let me draw PR and QS, and let's say they intersect here at point M. Okay, so the first property is that the diagonals, so I'm going to call diags, are perpendicular. Perpendicular. Remember that symbol for perpendicular is that upside down T. Let us also remember that perpendicular means we have right angles. So these 2 diagonals meet at M. That means that the angles here at M are right angles. So all 4 of them, 1, 2, 3, 4. I'm just going to put 1 right angle to keep my picture kind of not so crazy. The second property involved in the diagonals is the fact that the diagonals, the diags, bisect, opposite angles. So in this picture, P and R are opposite angles. What this means is that the diagonal PR breaks angle P into 2 congruent angles and angle R into 2 congruent angles. But let's recall that in a parallelogram, the opposite angles are congruent themselves. So if I break P into 2 congruent angles, then I break R into those same 2 congruent angles, and now along PR, all 4 of those angles are congruent. We do the same thing along QS. Again, because angle Q and angle S were congruent to begin with, when I bisect each of them, I bisect them into the same congruent angles. Now notice you have this right angle here, so Pythagorean theorem might come into play here, if you remember from Unit 4. So keep that in mind. Whenever you see right triangles, Pythagorean theorem is always a possibility. Okay, so that's our first special parallelogram. Okay, the second one, okay, is going to be a rectangle. Again, I'm pretty sure that you are familiar with a rectangle. So again, a rectangle is a parallelogram with 4 right angles. So again, we're going to draw a rectangle. We have typically one pair of sides is longer, one pair of sides is shorter. Let's call this WXYZ. Remember, we just go around in a circle starting in one corner. So again, in this picture, the 4 angles will be right angles. Now again, this has one property, so it has the other property. It also has to do with the diagonals. So I will draw in WY and XZ. Okay, now in this case, right, because this rectangle is not slanted, those two diagonals are actually the same length. So the property here in a rectangle is that the diagonals are congruent. So it's hard to mark that in this picture because they intersect. So I'll just write it down right here. So segment WY, segment WY is congruent to segment XZ. And then one of the things you'll see sometimes is that because the diagonals are congruent and because of the parallelogram and they bisect each other, you'll see this a lot. So if you recall in the parallelogram lesson, we would put a set of 1 dashes on one diagonal and a set of 2 dashes on the other. Well, now because the diagonals are congruent themselves, all 4 of those pieces are congruent. Okay, and I'm going to fit the last one down here. That last one is going to be a square. So a square is a parallelogram with 4 congruent sides, and 4 right angles. We can characterize this square, if you remember from the first lesson in this unit, as a regular figure. Because you have all sides congruent, all angles congruent, right? So a picture of a square looks like this, right? All 4 sides look the same. I'm not going to label it with letters. I'm just going to label the sides are congruent and the angles are all right angles. Now, quick little note here, right? Because this square is regular, right? I would suggest it's the most perfect parallelogram, right? It has all properties of parallelograms, rhombuses, and rectangles. Again, the most perfect parallelogram. We do focus more on rhombuses and rectangles, the squares not so much, but we are going to learn how to construct a square. So that'll be the last thing in this notes. So let us talk about that. So now we're going to learn how to construct a square. And again, this square is going to be inscribed in a circle. Inscribed in a circle. The upcoming unit, Unit 6, right, is going to talk about circles. So kind of good that we're, having some interaction with circles. Okay, so again, you're going to be given a circle with the center labeled, right? So here's my circle. There's the center. Okay, so step 1. And I'm going to try to make this go on one page if possible. It might be tough. So we're going to draw a line. Draw a line, and I'll underline line, through the center of the circle. This is going to give us a diameter. So essentially, you're creating a diameter, right? So again, we were given that plane circle. This is what we were given. So we're going to draw a line. I would just suggest you draw a horizontal line, right? Why make it difficult, right? Now, these 2 points here and here, the endpoints of that diameter, right, are the important parts of this. So make sure we have these 2 marked, and they will show up on the construction. Okay, so the second step is now we're going to construct the perpendicular bisector of the diameter. Now, I just want to talk about the one important part of this, is that you must open your compass greater than half of the diameter. So if you probably don't remember, right, how do you construct a perpendicular bisector? But again, one of the main parts is to make it go greater than halfway across. So I'm going to do it right here. So again, what we had was a circle at the center. We drew a line to create a diameter. So now I'm going to take my compass and I'm going to open it so it's bigger than halfway across. So there it is. And remember, I'm going to draw arcs above and below, right? And then I'm going to put and you can do a big arc if you want to. That's fine. And then I'm going to take it to the other side, right? I'm going to put it here now and do arcs above and below, and that creates my two intersection points that I'm going to then draw, and I'll change colors for this so you can see, but I'm going to then draw the perpendicular bisector down through. Right, there we go. And again, the important part is that it's perpendicular, it goes through the midpoint, and again, it creates two more points here and here. Okay, so then the final step, right? Step 3, you are going to connect the endpoints of the, and I did not explain this right, but when you drew this purple perpendicular bisector, you created a second diameter. So we're going to connect the endpoints of the two diameters. That will then make the square. So I'm going to come over here with it. So we had the center. We drew the one line to make this diameter. We just created the second line as the perpendicular bisector, created this diameter. So again, I'll change colors right now. So we're going to take this point, this point, this point, this point, and connect them to make the square. And there you go. And that's how you construct a square inscribed in a circle. So I'm going to do this construction for you on Delta Math right now. Okay, so here is my circle H that I have to construct my circle through. So again, the first thing we're going to do is we're going to take the line tool. I'm going to start on the circle and draw through the middle, right? Make sure you connect it to the middle. See, it created these 2 points. Now I'm going to take the compass. I'm going to open it up more than halfway across this diameter. There we go. And I'm going to put an arc way up here. Right. I'm actually going to do this. I'm going to make it a little bit bigger, and here's why. Right. I want the intersection of these to be away from this circle. Okay. So I'm actually going to make this almost so it's up here. Okay. And I'm going to put the arc up here and the arc down here. Right, so the longer you make that compass width, the better it will be for the intersection of the arcs. Again, you can draw one big arc if you wanted to. And then I'm going to take the center and move it to the other endpoint and draw a second set of arcs here and here. Okay. Once I have those 2 arcs intersecting, I can then take a line tool and connect them. It should also go through H if you do it correctly. Oh, give me 1 sec. Oh, hold on. Uh-oh. My tools are getting in the way, so I got to slide them over here. Okay. So the line tool from here to here. And notice it goes through H again, and it creates those 2 points. So now I'm going to take my segment. I'm going to connect those 4 points. 1, 2, 3, 4, and that should be my square. Woohoo! All right, so thanks for watching. Good luck on these special parallelograms.